Okay, continue.
An inequality of the form a1x1 plus a2x2 is less than or equal to b corresponds to a half space.
Okay, so
For
we
the
are
okay.
right. Thank you. So we are saying that like an inequality of the form a1x1 plus a2x2 less than or equal to b correspond to a half space. Now, if you see the less than or greater than, let me share it on the whiteboard. Okay, so if you see less than or equal to, it means you are going to draw a line that every straight line is equal to, like, so if the function is 20, we are just doing a recap because last time we did this one. So greater than or less than 5 is less than or equal to 5. So the equal to is the straight line. So the straight line becomes 20x1 plus 20x2 equals the 5. So that's the straight line. And the less than, when you see the less than, it means they are going to shade downwards. That's what the inequalities using the graphing systems is trying to teach us. So the less than, you shade downwards. Do you get me? Now, if the sign 2 is greater than or equal to, the straight line will be the equal to. The straight line will be the equal to. Then if it is greater than or equals to, the greater than, you shade at upwards. Do you get it? So basically, this is what they are trying to introduce to us under the graphing systems of inequalities. Inequalities, we have nothing like equal. So it's either equal or equal to or less than, or equal to or greater than. So basically, that's what they are trying to say. All right. Sorry. Okay. So that's what they've done here. So the greater than, you shade upwards. So that's what they've written, greater than or equal to. You shade upwards. Then on the straight line here, the black line here, the black line in the middle. The black line in the middle represent the equal to. Then the downwards. The downwards represent the less than or equal to. So it's for the inequality, a1x1 plus a2x2 less than or equal to b. Any point x1, x2 in the half space is a feasible solution. Now, I said in the previous video that when you are using the graphical or graphing systems of linear equations, that one is equation, to find the decision variables. That one you can only use the graphing systems to solve for the decision variables. Only if the decision variables are 2, that is only S1 and S2. So that one, you draw the line for equation, the mathematical expression, equation 1, you draw the line for equation 2. I've taught you how to develop the coordinate, formulate the coordinate from the equation. So you draw the 2 lines where they meet will become their optimal solution. So that one will become your value for x1 and value for s2. But with this inequality, you are going to shade either downward or upward. So you are going to get like where the shaded area meets, you are going to call it feasible region. So the feasible region, you are going to get hello. You are going to get multiple solutions. So we call that one feasible region. So you are going to get like plenty answers, but we are going to find out the optimum solution from it. So that's why we call it the feasible solution. Feasible solution means you are going to get plenty solutions, like which are likely to be the answer. But we are going to use a particular objective function, either to maximize cost or maximize profit or minimize cost, to solve for the optimal solution. And that is what we are going to learn under the linear programming. So basically, there is a difference between the graphing system of equality and graphing systems of what? linear inequalities. So with the equalities, where we have the equal sign, that one we are just going to draw the two lines where they meet becomes your answer. But with the linear inequality, you are going to shade either upward or downward. Where they meet, the shaded region becomes your feasible region. Then you use particular objective function to solve for the optimal solution. So basically, this is how the linear graphic systems of linear inequalities is trying to teach us. Okay, so any question before I move on? Any question?
No. Okay.
All right, thank you. So read this one for me. I'm coming. Let me copy it and okay, so please read this one for me.
A household has 300 Ghana cedis to spend on rice and soda drinks. A bag of rice costs 20 Ghana cedis and a pack of soda drink costs 15 Ghana cedis. Write and plot the area of a relation detailing how the available 300 Ghana cedis is spent.
So how many decision variables are we having in this type of problem? How many decision variables? So by definition, we say let x1 and x2 represents what? Number or units of bag of rice and pack of soda drinks. So for the unit cost of rice, we are getting 20. So the decision variables, we don't know the quantity. So x1 plus 15 x2. Now, reading the question, this one, they are talking about inequality. So there's nothing like equal to. Inequalities. It's not equal. So it is either less than or equal to, greater than or equal to. So household has, and I told you, when we hear has to spend, has available, at most, you are going to use less than or what? Equal to. So a household has paternity. When you have an amount on you, when you have a certain amount of years that you are having happiness on you, and you are going to shop with that amount of money, you cannot shop more than that 500 cedis you are having. You get it? So let's say the household is having 300 cedis. So the equation sign we use is at less than or equal to 300. And this one becomes our heart mathematical expression. Now we are now going to plot. They are saying we should plot the area of relation, detailing how the available 300 cedis is spent. And I have taught you how to develop the coordinates from this type of equation. So from this one, where x1 is 0, I have taught you already. So this one, just giving the answer. S2 becomes what? When x1 is 0, S2 becomes. So when x1 is 0, x2 becomes like this. So x1 is 0. So definitely, so s2 will be 15 s2. Right, so it will be 15 s2. Then we want the value of s2. So we just divide both sides by what? 15. So s2 becomes less than or equal to what? 20. Okay, thank you, boss. So s2 becomes 20. And the coordinates becomes 0 then 20. Okay, with the same thing, let's make s2 0, where x2 is equal to 0. X1 becomes x1 becomes for you. So the same procedure, just follow it. So if 20x1 plus 15x2, then we are saying the x2, we should make it 0. So 0.
15.
Good. 15. So the point will be 15 what? 0.
0.
Now we are having the two coordinates. So now we are going to plot it on the graph. You get it? I'm going to plot it on the graph. Okay, so here is 0. Let's make it 5. Interval, let's make it 5. 10. 15. 20. So this one becomes what? X1. Then let's make it here 5, 10, 15, then what? 20. So here becomes what? X2. So let's draw the first one. So the first one, when x1 is 0, x1 is 0, x2 is 20, it's going to be here, right? Second one, when x1 is 15, x1 is 15, x2 is 0, so it will be here. You're having the 2 points. Yes, you just joined the 2 points, so it will be here. Now, the straight line that we've drawn right now represent the equal to. So the straight line here, this one represents what? The straight line. So that one will be 20x1 plus 15x2 equal to what? 300. So I'm saying that always the straight line is equal to. Now it's less than or equal to. So I told you when it is less than, you are going to shade downwards. After drawing the line, you're going to shade downwards. If it's greater than, you're going to shade what? Upwards. So this one is less than. So where should we shade?
Downward.
Downwards. Good. So you shade to touch the S2 axis here or the Y axis. So you just shade till you get to the X1 axis or the X axis we normally know. Unfortunately for us, this one is having only one expression. So if there were two, you just shade the other one too. If it is downward or upward, you just shade it where they meet becomes your feasible region. So let's start the other one. Okay. Right. So let's move on to before that. Any question? Any questions so far? Any questions so far?
No.
All right. So Rich is saying no. What about the rest? Yo.
Yes.
Daniel.
I beg how you solve the question. The question has to be solved. Now my next week is so I'm not sure.
Okay. So can somebody be my lawyer? Just explain it. Can someone be my lawyer?
I can't my network. I don't know if you can hear me. Hello. Hello, can somebody hear me?
Yeah, boss, you can hear you. So just talk.
Yeah, you can hear you. We use the what do we call it? The equation from the word problem. So we have 20x1 plus 15x2 is less than or equal to 300. So when we are done with that, we have to what do we call it? The x factor. So you just make one the subject by make equation 1 to 0. So assuming you want to find the coordinate of x2, you just make x1 0. So then when you make x1 0, you will get 15x2 less than or equal to 300. Then that one you divide by the x2 coefficient, that is 15, which will give you 20. So when you're done with that one, the coordinates will be 0 for the x1 because we placed 0 there, and then the other coordinate will be 20. Can you hear me? Can you guys hear me?
Yes, we can hear you. Yes, please.
Hello.
We can hear you, boss.
Good. So the second one too, you equate the x2 factor to 0, and then you find for x1. So that one we will get 20x, yeah, 20x1 is less than or equal to 300, and then you divide by the x1 coefficient, which will give you 15, and then your other points will be 0 because you equated the x2 to 0. So when you're done, you plot your graph. You have 2 points. You just plot where you find your first coordinate, that is the 0, 20. So the 0, 20 will be on the x-axis now as the x2 axis, and then the 15, 0 will also be on the x1 axis. So when you're done, since it's less than or equal to, you just sit downwards. That's it. Nah.
Okay, so basically, has he answered your question, or you are talking about the formulation of the expression here? Hello. Hello. Bastios. Bastios. Hello, Bastios. Bastios.
How is it?
You senior.
For me, from Saunya, we equate.
Okay, so please listen to me here. So we are saying for you to formulate expression like this from word problem like this. One, you first of all consider your decision variables. Now, how many decision variables are you talking about? Now, the decision variables are the product in question. So here we have rice and soda drinks, and we are not interested in the rice and what? Soda drinks alone, but we are interested in their quantities, their unit, their amounts. You get it? So first of all, you let S1 and S2 represent the number of bag of rice and what? Pack of soda drinks. We don't represent S1 and S2 by the rice and soda drinks, but their numbers that we are yet to buy, that is unknown. If that one is clear, I think I can continue. So the X1 and S2, the decision variables are interested in the quantities, the units, the variables. You get it? So we are interested in the quantities of the product in question. We are not interested in the quantity or the unit. Do you get it? Good. So we this one, the decision variables are rice and what, so that means. So let's say you enter the supermarket and you are having 300 cedis. Now you are planning to buy rice. Oh, sorry, okay. It relates to the price of what? Soda. The same thing related to the soda drinks. So we are saying that to know the amount we spend on total soda drinks is the unit price. That's the 15. Well, one pack of soda drink is 15. But we don't know the quantity we can buy with the 300 cedis in hand. So times the quantity we don't know. And we said that we should represent the quantity with S2. So we have our total revenue for soda drinks to be what? 15x2. And now we are saying that to know the amount we can spend on rice and what soda drinks, it is what? 20x1. That's the price of rice plus 15x2. Then this one is inequality, and I said inequality. We don't have anything like equal to like this, no. So it is either less than or equal to, greater than or equal to. So, and I gave you a clue that when you hear has something to spend, has available, at most, you are going to use less than or equal to. When you hear at least, you are going to use greater than or equal to. So this one, they are saying that the household has 300 cedis to spend on rice and soda drinks. So if you have something to spend, you cannot spend more than what you're having. You enter the mall, you're having 1,000 cedis for your small shopping or something like that. You cannot spend more than the 1,000 cedis you're having. You get it? So we just represent that one with greater than, either you spend the 300 cedis or you spend less than the 300 cedis. So less than or equal to what? 300 cedis. So this is how I ended up with the expression. Now to get your coordinates, now we are having this expression here. You're having this expression. You have to get a coordinate to plot what the graph. So how do you get the coordinates from this kind of what expression? So we are saying that first of all, you represent x1, the x1 here, you represent it with what? 0. So when x1 is 0, what to be the value of x2? So we did that one, that calculation. So if x1 is 0, so 20x1, we are saying we should represent the x1 to be 0 for now, plus 15x2. You get it? Greater than 300. Now this one becomes 0, so it will cancel off. So it will be left with what? 15x2. Now we want to know the value of s2. How do? We divide both sides by what? The 15 we are having as the coefficient of s2. So 15 here, 15 here. This cancel this is going to it how many times? 20 times. So the s2 becomes what? 20. Then you get your first coordinate. 20. Let's say just we are using x and y, but here they say we should use x1 and s2. So x1 represent the x axis, s2 represent the y. So the 20 like this. So this is your first coordinate. You are going to follow the same method, the same procedure to find the value of what? S to S1. So this one, when x2 is 0, x1 becomes what? So by the same, following the same calculation, you get it to be 15. So that one to your coordinate will be 15, 0, like this. Then you plot it. So the 0, 20 will be here. The first one will be here. 0, when x1, this one is x1, this one is x2. So when x1 is 0, s2 is 20, it will be here. The second coordinate, when s2 is 0, s2 is 0, x1 is 15, so that one will be here. Then you join the line, you draw it like this. So the straight line will be the equal sign. The straight line will be the equal sign. Then with the linear inequalities, when we see the line greater than or less than, after drawing the line, you shade downwards. You shade downwards. When it is greater than or equal to, after drawing the line, you shade what? Upwards. So that is what we've done here. So this one, it was only one equation. Oh, this one is inequality. So one mathematical expression. You get it? So if we have to, that one too, we will draw, we will shade. Wherever they meet becomes our feasible region. That's where we are going to find our possible answers. So within the possible answers, you get our optimal solution. You get it? But with the previous video we did, with the equality one, that one, you just draw the line, you don't shade. So you draw the two lines, wherever they meet, their intersection point become the value of what? You trace it down, the value of x1 become the value of what? The x1 in terms of decision variables. You trace it to the s2, the value you get will be your what? S2 value. But with the inequalities, you are going to shade. Basically, so this one was just one and we plot it on the what? The feasible region where the you get it. Right, so any question? Any question before we move on? Any question before we move on, please? Bastios, Fifi, Regan, and are you okay? Like, can you continue? If you can't talk,
Yeah.
All right. What about the rest? If you can't talk, just chat in the chat forum. I'll just reply to that message. All right. So, okay. So let's continue. All right. Can someone read for me? Can someone read for me? Oh, someone should read it for me.
A household has 350 to spend on rice and soda drinks and 35 cedis to spend on transporting them to the house. A bag of rice sells for 20 cedis and costs 1 cedi to transport. A pack of soda drinks sells for 15 cedis and costs 2 cedis to transport. Write a relation detailing how the available money is spent on the items and plot the area covered by this relation.
Okay, so how many decision variables are we having? Thank you very much for reading it. How many decision variables are we having? Oh, we've done the two. So they are
X1 and X2 for the quantity of rice and the pack of.
So let's X. So the decision variables, with the decision variables, we are interested in their quantity or the unit. So let X1 and X2 represent what? The number of bags of bags of rice. So with their units, so bags or bag of rice, I don't know, bags of rice, and packs of soda drinks, that is unknown, the quantity is unknown, respectively. You get it? So now, what is the unit cost of the rice? It is 20. So 20x1 plus, what is the unit cost of the soda drinks? It is 15, so 15x2. Now, first of all, we are dealing with resources constraint number 1. That is the amount spent, 350 Ghana cedis here. So if you have something to spend, you cannot spend more than what you're having. So it is less than or equal to 350. Less than or equal to 350. That's the first resource constraint. The second resource constraint has to do with the transport. So that one too, we have an amount to spend on the transport. So we are saying that we are having 35 cedis to spend on transporting them to the house. Them means the rice and the pack or the soda drinks. So now we are saying that when you buy the bag of rice, the amount you are going to spend on transporting the rice to the house is what? 1 Ghana cedis. So it is 1x1. So you don't write 1x1, just write x1 plus the amount you are going to spend on transport. You're going to spend on transporting the soda drinks from the place you bought them to the house will be what? 2 cedis. So 2x2. So that one, they gave us 35 cedis to spend on what? The transportation alone. So that one, you have something, you cannot spend what more than what you're having. You get it? If you have 10 cedis, you cannot spend more than 10 cedis. You use exactly 10 cedis or less than 10 cedis. So less than or greater than 35 Ghana cedis. So this one, the one has to do with the amount to spend. The 2 has to do with what? The transportation. So we formulated our expression. So any question before we move on? Any question at all? Any question? Any question? Any question, please?
No question.
You said?
No question.
The rest? Come again with the second equation. All right. So with the second equation, we are saying that we were given 35 cedis to spend on what? Transport. So that one becomes our resources. So the resources comes after the equational or inequality sign. You get it? So that's the 35 cedis here. And we are saying that a bag of rice sells for 20 cedis and cost of what? 1 cedi to transport them to the house. So it will be 1. And what is the decision variable for rice? It is what? X1. So we don't write x1, 1x1. We say that 1x1, x1. 1x1 is equal to the x1, but the coefficient 1, we don't write it. And the the soda drinks, the 1 pack sells for what? 15 cedis, and it costs 2 cedis to transport them from the warehouse to where? The house or your house. You get it? So that one to plus. So x1 plus the price is what? 2. Then what is the decision variable for pack of soda drinks? When you transport 1 of them, you are going to spend 2 cedis. How much are you going to spend? Because you don't know the quantity you are going to buy. So when you buy 1 pack of soda drinks, you are going to spend 2 cedis on the transportation. So if you buy 5 packs, it is 2 times 5. That will give you 10. But here is the case: we don't know the quantity to buy. So we represented that one with x2. So we just multiply the x2 with it. Then this one is inequalities. When you have something, the household is having 350 cedis. So in terms of transport to the household is having 35 Ghana cedis. You cannot spend more than what you're having. So it is either equal to or less than what they've mentioned. That's why they got 35. And this is how we came about the second expression. Is it okay now, Fifi? Is it okay now? Okay. Okay, sure. So we can continue. So now that we are having the expression here, we are moving on how to plot, because they are saying that we should plot the area covered by this relation. So we are going to plot these two relations on the graph. How are we going to plot them? We cannot plot the inequality or the expression here. We have to develop what the coordinate. How are you going to develop the coordinate? So that one is here that for the equation one, or equation one, when let's represent S1 with 0 to find the value of S2. S2 will be what? We've done this, so just do it and work it for me. Please, I'm waiting. What will be the value of S2? You've done it, so this one to have to work it again. It will waste time. So first of all,
23.33.
Okay, 22.8, but okay, thank you. So 15x2 less than or equal to at 350. And we are saying we should represent the S1 with 0. So the 20 times 0 will be 0. So it will be left to that 15x2 less than or what? Greater than 350. And we are searching for the value of what? X2. So what will be the value of S2? So just divide both sides by 15. This one will cancel off. So S2 will be left with what? Greater than or equal to what? We are saying 23 point what? 33. I'm not having a calculator, so just do it for me.
23.33.
So 20.3.30. Now in SHS or GHS, the S2 will represent the X, S1 will represent X, S2 will represent Y. So this one, this is how we write it. So it is 0, then comma 23.33. I hope you remember how to write this coordinates.
Yeah.
Yes. And like equation one, we have to get two coordinates. We've gotten the first one, so let's move on to the second one. So the second one to represent S2 is 0. So when S2 is 0, what will be the value of X1? What will be the value of X1? Follow the same procedure here. Just let X2 be 0.
17.5.
17.5. Thank you. So how do you write it? The X1 comes first, so 17.5. Comma 0. Okay, so this is the coordinate for equation one. Sorry, this one is inequality. So I cannot use the word equation because it's not equal to. Yes. So let's plot the first one here. Yo. Yeah. So this is 0. This one becomes your X1. S2 in SHS, you just write Y axis, X axis, but they are saying you use S1 and S2. So let me do it. I don't know if I should do it 10 or I don't know, or 5. 10, 15, 20, 25. We use the same scale for the S2. 5, 10, 15, 20, then 25. Okay, so let's draw the first one. So if this one is x1, this one is what? X2. So if x1 is 0, if x1 here is 0, x1 is 0, s2 is what? 23.33. So where do you think that one will fall? Is it on the s2 axis or on the s1 axis?
x2 axis.
S2 axis, so it will be here. 23. So this one is not drawn to scale, so let's use something like this. So the second one to when x1 is 0, 17.5, s2 is 0. So it will surely come here. So 17.5. Let me use place like this. Then you join it. Right? You just join them. So this straight line here becomes your equal to. Your straight line becomes your equal to. So you write the equation there. So 20x1 plus 15x2 equals to 350. Because I said every straight line is equal to. Then this one is less than or greater than. So what do we do? Less than or greater than. So we shade what? Is it downwards or upwards? Hello, this one is less than or equal to. So are you going to shade downwards or upwards?
Downwards.
Yeah, so you shade to cut the S2 and X1 axis. So you didn't shade to like go beyond the straight line you've drawn. The ending point should be on the straight line. Just make sure it cuts the S2 and S2 and S1 axis. Now the shaded area here, that one to give it a name. That one too becomes your 20x1 plus 15x2. Then that will be greater than, less than or equal to what? 350. You get it? So now we are done with the equation 1. Now let's move on to the equation 2. So for equation 2, we are going to get the coordinate for equation expression 2. This one is inequalities. Why am I saying equation? I even used the equation, sorry. So for expression 2, mathematical expression 2. So let me change this one to expression or inequality. Or inequality. Equality 1. Inequality. Okay, so this one we are going to follow the same procedure. So first of all, when x1 is 0, please do it for me. What will be the value of x2? What will be the value of s2? What will be the value of s2? Hey, I don't talk now. How will I know you've understood that thing or you've not understood it?
8.75.
Is that
when x1 is 0,
A2 is
x2 becomes 8.75.
come again, because 35 divided by 2.
Is it 2 or 4? Is it 2 times 2?
No,
17.5.
2x2
It's 17.5.
all right, thank you. So 17.5. So the coordinate then becomes 0, then 17.5. Then let's move on to, let's represent the S2 with 0. So when S2 is 0, what will be the value for X1?
35.
35.
That one
Thank
will
you.
be 35.
All right, thank you. So it will be the S1 is first, comma S2. Okay.
I thought you are using inequality, so where from the equal to or
So this one we are
from
just
this,
deriving the coordinates, so the equal sign, it doesn't matter.
so it doesn't affect your work.
No. This one we are deriving the coordinates. So we have to use the equal sign.
Okay.
You get it?
Yes, please.
All right. So that one we plot the line for equation 2, inequality 2. So that one too, let's plot that one using different curve. So when x1 is 0, S2 becomes 17.5. So will it be on S2 axis or on S1 axis?
X2.
S2, so it will be here 17.5. So somewhere here. Then when S2 is 0, S1 is 35. Then I have to extend. Come on. I have to extend this one, sorry. So this one will be 0.35, so it will be here. We are getting your 2 points. Just join them. Hey. Someone's microphone is distracting us. All right, thank you. So this straight line too becomes the equal sign. So just write it there. So x1 plus 2x2 equal to, on the straight line, every straight line is equal to 35. Then this one is less than or equal to. So where are you going to shade? Downwards or upwards? Downwards, right? So you shade to cut here. To get to where the other point is. Okay. So the shaded area too. So the shaded area for this one two becomes x1 plus 2x2 less than or equal to 35.
Your class.
Pastors, please, I beg, mute yourself, give me. Pastors. Okay, so let's continue. So we are going to shade where they meet, the shaded region meets. So I'm going to see that now. Wherever you see the red line and the yellow lines will be where we are going to shade. So the red line was from this part to here, from here to this part, because here you cannot see any red line there. So we are going to shade up to this part too, because here too you are not finding or seeing any yellow line there, right? So you shade up to this part. Shade up to this part. So then within here, so within this place will be the what shaded region. So in this region is where we call it the feasible ones region. So within this place, you are going to get what possible answers. So they here with the inequalities, the answers are not only one, like compared to the equality one. The equality one, you are only having one answer, but with the inequality, you have more than one answer. Then you work to find only one. You get it? Abba. Oh. I hope you can see where you can shade, because using the amount. Oh. Even tired. So this becomes our shaded region. So within this region is where we are going to get our final answer. But we are going to get more than one answer. So when you get to the linear programming, we are going to use the objective function to solve for the answer we are looking. If it is cost, you will find the least value. If it is profit, you will find the what maximum value. So the point will be here. First of all, one is here, one is here, the meet here too. The other one is here as well. So we're going to get 1, 2, So these are your points. So you are going to get 0, 0, 0, 23.33. Then 17.50. And the last point, I don't know if it is 10 or 17 point something. Yes. And you are going to choose these answers. So you are going to write down the coordinates. Then when you reach linear programming, you are going to use the objective function given. If it is profit, you are going to use the function given. You substitute the coordinates in it. You solve for the values. So if it is profit, you are going to select your highest one. If it is cost, you are going to select your lowest value. And that one, those coordinates becomes your what? Value for x1 and s2. So any question? So they are saying any point inside the common shaded area is solution because it is what? It satisfies both inequalities. So this point satisfied these two inequalities. So this shaded region, the green area, so you are going to find our optimum solution. All right. So they are having another question here. That one I'll leave you to solve, but they formulated everything for you. They formulated everything for you. They formulated everything for you. So you just follow it. This one, it is having the same two decision variables. That is rice and what? Part of rice and part of soda drinks. You get it? You're having the same thing there. I hope you can do this. This one is not difficult. You've done this several times. You get it? So after doing that, you plot these ones on the graph. It's not difficult. Try it. If you're not able to do it, then you come back to me personally. I'll teach you how to do it, because if I'm to do this, it will waste time. But the same thing we did, but just that the expressions are 4. Unlike the one we did, it was 2. You get it? So it's the same question. You do it the same as this one. All right. So in the next video, we are going to learn the linear programming. All right.